Hello students. So today we are going to read number system, which is a CBSE syllabus of class 9, and it is your chapter number 1. It is for class 9. Okay, so number system for CBSE chapter number 1. Chapter number 1, class 9. So this is for chapter number 1. Okay, so into this session, into this chapter, we will be mainly focusing on 6 different sections. Okay, and so will be my lectures onto it. So we will first start with introduction to the number system, where I'll explain you the different kind of numbers, like whole numbers are there, natural numbers are there. So we will be briefly talking about the different kind of numbers into our number system, and on rational number as well. What is a rational number? Which number is not a rational number? So once we have talked about rational number, we will then be coming on the irrational numbers. So once you have come to know what are rational numbers, so you should definitely know that what are the irrational numbers, and then we will be coming on real numbers, and we will have some decimal expansion, which I'll tell you in my subsequent videos. Then we will have to represent a real number on the number line, and it's much easy. I'll show you into complete pictorial diagram and all, so you will be well able to understand. Then we will be having some operation on real numbers, like addition, subtraction, division, multiplication, okay, and even rationalization. Next we will be coming on surds, or means the laws of exponent for real numbers. Okay students, so let's start with the introduction to number system. Number 1. Okay students, so because the name of the chapter itself is number system, we will just get to know the definition. Okay, now you can see 1, 2, 3, 4, 5. 5 different kind of numbers over here, correct? So the definition goes on as the collection of numbers is called as number system. Okay, so it will have different types of numbers, such as natural number. So what are natural numbers, students? Natural number are those numbers which start from 1 and they go till positive infinity. They go till positive infinity. Okay, so what are the whole numbers? The difference between the whole number and natural number is whole number starts from 0 and natural number starts from 1. That's the difference, and this also goes till your positive infinity. Okay, this also goes till your positive infinity. Okay, now always remember this whole number means this whole number. How to remember? Just the difference between natural number and whole number is of 0 and 1, right? Okay, so 1 is even there into the whole number. So whole number means whenever you are asked what is a whole number, just say start from 0. Okay, natural number means those are actually numbers, okay, which either you subtract or divide, they will cause some effect. They will either increase your number or decrease. Okay, so those will become real numbers, which are not starting from 0, but the whole number will start from 0. Whenever you are asked about whole number means you will take the complete set of numbers that okay, but only positive, and into that 0 will be there. Natural number means those numbers which are actually numbers. If you talk about integers, any value which starts from negative infinity and -3, -2, -1, 0, 1, 2, 3 dot 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 till positive infinity. So any value from negative infinity to positive infinity. And actually integers, you know how you do, how do you define integers? Just write it down that integers are those whole numbers. Integers are those whole numbers which can be positive, and they can be negative, and they can be zeros. Okay, so they can be negative, positive, and zero. Okay, so those are the integers. Then we will be coming to rational numbers. You see, they're saying that any number which can be expressed in the form of p by q. Okay, where p and q are integers and q is not zero. Suppose 1 by 2 I'm saying you, so it's a p, it's a q. Okay, so 1 and 2 are integers, correct? They're into the list of integers, and this q is not zero. Suppose 1 by 0 I'm giving, so 1 by 2 will be a rational number, but 1 by 0 will not be a rational number. Okay, so now let's talk about the irrational number. Irrational number are those numbers which cannot be expressed in the form of p by q. Suppose 1 by 0, it's an irrational number. Okay, okay, so now I hope you have understood the definition of the number system. Okay, the collection of numbers, that is only called as the number system. And into your number system, you will have different kind of numbers: natural number, whole number, integer, rational number, and irrational numbers. And student, what are rational numbers? Okay, so the rational numbers are usually the collection of all the rational and irrational number. Those are called as real numbers. Okay, these real numbers are denoted by r. And yes, what I forgot is the annotations. Okay, for different numbers: natural number n, whole number w, integer I, real number r. Okay, so the real number is denoted by r. Now you see that every real number, okay, is a unique point on the number line. Number line is, you know what, like we have a scale, right? So at that time only the number line is there. You will better understand when I'll be writing it down. Okay, so now we will come to know two terms. Okay, which are terminating and repeating decimals. So now we'll be discussing the two terms, which are the terminating decimal and repeating decimal. We should have our concept very clear onto these two terms. So let's talk about a terminating decimal. I'll be starting with an example. Okay, suppose I have a number which is fraction, which is 1 by 4. So what is the meaning of 1 by 4? How to convert it into decimal? So as we all know, okay, so this 4 will divide 1, isn't it? So this happens. So we'll put a dot and it's 0.2. 4 2s are 8. Okay, it's a minus, and then comes to, again for this decimal we'll be getting a 0, and 4 5s are 20, and we got the remainder as 0. So since we got this remainder as 0, so everywhere a fraction, okay, whose remainder will be 0, okay, that will be called as terminating decimal. Okay, let's talk about a repeating decimal. Suppose we are taking example of 2 by 3. So what is the meaning of 3 by 2 by 3? So 3 will be dividing 2, isn't it? So for a decimal 20, 3 6 are 18. Again subtraction, 0 2 2 came. Again for a dot 20, 3 6 are 18. 2 again for a decimal 20, 3 6 are 18. So you will keep getting it 0.666666 dot 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 dot. So this is if you are getting this kind of number, okay, this kind of number is further written as 0.6 is been repeated now. So let's write 0.6 bar. Okay, suppose the number is like this: 0.125, 125, 125, and so on. So you see 125, this pattern is repeated: 125, 125, 125. So your answer will be 0.125. Okay, understood? So what is it? This is a repeating decimal. Now, why am I telling this? Because our next concept, okay, we will get to know that what are rational numbers. So if you want to know what are rational and irrational number, your terminating decimal and repeating decimal, your concept should be very clear. So if you want to write or just want to hear the definition, okay, I'll tell it for you. Now you see, for those terminating decimals, the decimal expression, it should terminate, like here it terminated, right? Okay, it should come to an end, then only the decimal is called as terminating decimal. If the decimal does not come to an end, or the same number repeats, the same digit, the same number repeats, or same set of number repeats. You see 0.125, 125, 125. So either a set of digit will repeat or one digit will repeat, okay, for n number of times, and it is not ending. So in that case, that decimal is a repeating decimal. So 0.66 is this is a repeating decimal. Okay, students, so this was all about the terminating decimal and the repeating decimals. So students, I made a special note for you people that what are the rational numbers, which kind of numbers will be the rational numbers. So number one is, every rational number is expressible either as a terminating decimal or as a repeating decimal. Every rational number will be expressible either as terminating decimal. So they could be either terminating decimal. Suppose I got 0.25, okay, that's the end of the decimal, and that's the end, or as a repeating decimal. Okay, so if you want to get it clear, I'm having this further explained over here, that every terminating decimal is a rational number. Okay, every decimal that terminates, so that will be a rational number. So they will be either terminating in nature, like I told you 0.25, or they will be repeating 0.125, 125, 125, 125. So you see over here, same sets, there are, this set is repeating itself. This can be written as 125. So this can be written as 0.125 bar. That means if you remove this bar, means 125 will be occurring n number of times. Okay, so what is a rational number? A rational number which is either terminating or repeating. Either it should terminate, and if it is not terminating, then it should be repeating, like 0.3333, 0.6666, 0.9999. Okay, so these are repeating and this is a terminating. Understood? These are repeating and this is a terminating decimal. Okay, now if the rational number is in the form of a by b, then by dividing a by b we can get two situations. So wherever you will be getting a fraction, okay, that has to be classified either as rational number or irrational number. So that can be written as, suppose I'm talking about one fraction where the remainder becomes 0, like for 0.25 that I have shown you over here. You see, for this, the remainder will become 0. So, since the remainder is becoming 0, so this is a this is a terminating decimal, isn't it? So, this is a terminating decimal where the remainder is getting 0. So, that is a rational number. And if the then the remainder is not 0, but still your quotient is repeating in nature, your quotient is repeating in nature, then it will be called as repeating decimal, and every repeating decimal is a rational number, like we read over here into the notes that I have made for you. Every repeating decimal is a rational number, every terminating decimal is a rational number. Okay. So we have read both the cases that I made for you, right? Here we took the example of 0.25, and here we took the example of 0.6666999999 dot 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 dot. Okay. And one more term is there. Okay. Finally, just read it out. The decimal expansion, okay, of rational numbers, they could be terminating or they could be non-terminating. They could either terminate or they could non-terminate. If they are non-terminating, they should be recurring, means the same number should repeat, same digits should repeat, or same set of digits should repeat. So here 125 was repeating itself again and again, and that's why 2 by 3 is a rational number. Since it is this decimal terminated, that's why 1 by 4 is a rational number. Okay.